Hi. Importing complex geometry in SolidWorks can be a daunting task. Import diagnostics can take hours, deforms the model, and fails more often than not. Since every part must be flawless to run an efficient model, it must be corrected. This tutorial shows how to do it for any format from STEP to DWG. We begin with a clean import. Activate 3D Interconnect for best solver and disable import diagnostics. Do not start import diagnostics. Break any links to the original file. Go ahead and delete all part appearances. If you want to keep the colors, first save a copy of the part and then reapply them later. Save this in IGES format with these settings. Under Import Options, disable 3D Interconnect and Automatic Healing. Select Do Not Knit. Open the IGES file you just saved. If a folder structure appears, you can delete it. Your part is now a group of unrelated surface bodies. Save the part and give it version number 1 to keep track of all the changes. Change the view to shaded with edges. Delete one random body and immediately undo the delete. SolidWorks will now show blue edges. Save your work. Imported and engraved text can be very system heavy. Consider deleting it. Hide the main text surface. With section view, you can isolate surfaces belonging to the text. Go ahead and select all the text surfaces and hit Delete. Select the Delete feature. Unhide the main text surface. Activate the Delete Whole command. Select the text area and confirm. Go ahead and deactivate section view. You can also delete other unneeded features. Select all internal surfaces and delete. Activate the Delete Hole command. Select the edge geometry of the hole and confirm. Do not forget to close both holes for true and true features. From now on, we save as Parasolid. The Parasolid format ensures error-free translation. Close the part. Open the saved Parasolid file. Under General Import Options, reactivate 3D Interconnect. Stay away from diagnostics. Save the part under a new version number before we move to the next step. In this step, we start joining single surfaces into multi-surface bodies. Start knit surfaces and make sure Create Solid and Merge Entities is off. Create clusters of surfaces with about 20 items maximum. Make sure no previous group is selected when you make a new group. Continue making groups till you have roughly 25 features and repeat the export to Parasolid and import process. With each iteration, the model will become quicker. For now, avoid big surfaces. All surfaces with a warning should be color marked for repair in a later step. If the surface is small or adjacent surfaces look bad, add them as well. If you spot any deformed edges or surfaces, mark them as well. When the smaller, unjoined areas become limited, you can start joining together the bigger blocks you previously joined together. If at some point knit surfaces fails, you probably have a bad surface. Try to pinpoint the bad one by playing with the selection. In this case, the error is zero thickness geometry. Another possible error is self-intersecting geometry. Continue knitting surfaces till the count is less than 200. Time to get our first error fixed. Reduce the area to fix as much as possible. Create a sketch on the error surface. Select Trim Surface and decide to keep. Next, we select Filled Surface and select all the edges. Zoom in and don't forget any small edges. With the Mesh Preview option, you can spot bulges or deformations. Usually this happens because of forgetting small edges. Select Merge Result to knit them with the neighboring surfaces. We do the same for the other side. Make a sketch on the same plane and draw a line with two random points. Select Filled Surface and mark all the edges. Use Merge Result and confirm. Use the Delete Face command to delete all surfaces touching the error. For complex surfaces, first create a 3D sketch to save geometry. Start another sketch on the main surface. We use half a circle to divide the error zone in two. Close the area with a line. Exit the sketch and go to the Filled Surface command. Select all the edges. Repeat the process for the last section. Now we recreate the cylinder face. Create a 3D sketch and draw a line going straight up. Use Surface Sweep to recreate the face. End this repair with knitting the surfaces together. Another common error is duplicate and extended surfaces. Start the Delete Body command. You can easily select the duplicate via Select Other. Add all the duplicates and confirm. Next, we trim the surface. Start the 3D sketch and draw corrected geometry. Go to Trim Surface and select the surface to trim. Repeat this process for the other surfaces. The next mistake is far more complex. We start by deleting the bizarre mixed surface. To better visualize, it's handy to give the rear faces a different color. Use Section View if needed to better see the work area. Hide faces if needed to isolate problem faces and stop sketches from adding relations to other bad surfaces. Here we have another phantom surface to delete. Make a sketch to reconstruct the damaged surface. Avoid complicated sketches. Better extend and use the edges from the existing geometry. Finalize with filled surface to complete the repair. Hide the fixed surface and unhide the next for repair. We see that there are problems with the bottom and side of the surface. Create a sketch to cut off the bottom part. With trim surface, cut off the bottom section. This edge also looks far from fluid. With offset surface set to 0, we can duplicate the surface. Select the old surface and delete. Make a 3D sketch to complete the surface. Point of attention when you reference old or bad geometry that still needs to be deleted. When the sketch is complete, swap the relations with fixed ones. Add another filled surface based on that sketch. Don't forget to change to tangent as boundary condition when flowing out of curved faces. Now we can unhide all the hidden surfaces. The final step is correcting the bottom surface. Start trim surface. You can use the rebuild surface as cutting line to trim the bottom surface. All surfaces are now corrected. Terminate section view. To finalize this repair, we knit the corrected surfaces together. If you need to unknit a single surface, you can do the following. Start offset surface and select the face. The offset value is set to 0 and confirm. Hide the new offset surface. Use the delete face command to remove the old face from the surface. Unhide the offset surface. In step 5, we take on the last single surfaces. Restart knit surface, open the surface body list and select from here in small groups. These can be unreachable insides, missed ones or internal surfaces. Only start this process when the surface body count is getting low. When the knitting fails, start by removing surfaces till you have found the bad surface. In this case, we found floating internal surfaces. Use the delete body command to delete those surfaces. Most errors occur multiple times on symmetric parts. Repeat this process where needed. Now we can knit the remaining surfaces. Under Knit Surface, activate the Create Solid option. You now have one solid body. In this last, sixth step, we export one last time to Parasolid. Import options are rather irrelevant for Parasolid and can be default. Once the model is re-imported, go ahead and run the import diagnostics. The model should be error-free now. You can also perform an entity check to be sure. Reapply the colors from the original import if needed, just copy and paste. Save the model, and that concludes the repair.